right, so we are starting our arithmetic series. So far we've been dealing with our sequences, and that's creating your little list of what your terms are. So now we're getting into our series, which all that a series is, it's the sum of the terms of your sequence. So you just take your sequence, add your terms together, and now it's a series. That's the only difference. So let's take a look at our first example here. Find for me the sum of 5 plus 10 plus 15 plus 20 plus 25 plus 30. Add them in your calculator. 5 plus 10 plus 15. What was that, Luke? All right, Luke got it for us, 105. So next one says find the sum of the numbers from 1 to 10. So that'd be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Oh, Sean got us this time. 55. So it's actually a pretty easy concept. You're just adding your numbers together. The tricky part comes in is when they tell you, like in our next example, to find the sum of the numbers from 1 to 200. You don't want to be sitting here writing out 1 plus 2 plus 3 plus 4 all the way up until 200. So we have a little formula for us.
Have you ever had to do that?
Where it starts with S sub n equals n times your a sub 1 plus your a sub n all over 2.
Now it's not one question.
Hmm?
Don't skip over.
No. So one thing is, you do have to memorize it. This one's not going to be given to you. This is the one formula of this unit that is not given to you. So we got to memorize this one.
Because it's not necessary.
No, it is necessary.
You could do it without it.
Yeah, it would just take you forever. So the S represents our sum. What does the N represent? Number of terms. Our a sub 1, that's our first term. And then your a sub n in this formula represents your last term. So for example, if they want you to find the sum of the first 25 terms, your last term would be your 25th term. So you just got to make sure you know what that term is. So now using that formula, we can find our sum. I'm going to write my sum formula again because you have to memorize this. So the more times you write the formula, the more likely it is you're actually going to remember it. So we'll write it again for example number 1. So we're finding the sum from 1 to 200. So what would our n be? How many numbers do we have? 200. So S sub 200 equals 200 times. Our first term is 1, and then plus our last term, 200. And then we're going to divide by 2. So let's have you figure out what that is. 20,100. So our next one, find the sum of the first 50 terms of the sequence 3, 5, 7, 9. So again, I'm going to start off by writing my sum formula to help us remember it. We're trying to find the sum of the first 50 terms. So what would our n be? 50. So S sub 50 equals 50 times. Our first term is 3. Our last term should be our 50th term, but do we know that yet? No. Okay, so we need to go figure that out. So in order to figure out your 50th term, we got to think back to the other formulas that I have given you so far this unit. With an arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times your d. That gives us our 50th term. So a sub 50 equals, our first term we said was 3. Plug 50 in for our n. What is our d? What are we adding each time? 2. So go ahead, figure out what our 50th term is going to be. So now we can plug in our 50th term of 101 and finish off our sum formula. Hopefully you get 2,600. That's what I got. See, not so bad. Easy peasy. So let's go take a look at our next example, example 3. We're told our first term is 4. Our sum of the first 40 terms is 6,080. They want us to actually find the 40th term.
Was the name of the last one 2,600?
Yes. So let's again write our sum formula. And then let's go through and plug in what we know. What is our n going to be? 40, but I don't actually want that first. Our sum, which I'm going to put in for my s, they told us was 6,080 because they said s sub 40, so that means our sum of the first 40 is 6,080. We're going to put 40 in for our n. A sub 1 is a 4. So 4 plus your a sub 40, because again I put my 40 in for my n, all over 2. So now we just need to solve this. How do we get rid of our 2? Multiply times 2. So 6,080 times 2. To get rid of the 2. Yep, now we would want to divide by 40. And when we divide by 40, what do we get? Yep, 304. So then we subtract our 4, and our 40th term is 300. So that's just us manipulating that same formula in a slightly different way, but it still works. And we knew to use that formula because it talked about the sum, so you had to use your sum formula for that. So example 4, we're finding the sum of the first 6 terms of the sequence 2x plus 3x minus 1 plus 4x minus 2 in terms of x. So again, finding the sum, so I'm going to write my sum formula. What's our n? N would be 6. You're finding the sum of the first 6 terms. Your n is going to be a 6. our first term? First term would be a 2x. Do we know our last term, our sixth term? No, so we got to figure out our sixth term. So we got to step out for a second. Go back to our other formula we used for arithmetic sequences to find our terms. So we're trying to find our sixth term, so a sub 6. Our first term we said was 2x. And then it's going to be 6 minus 1 in the parentheses. What we have to figure out is our common difference. What am I doing to get from my first term to my second term?
Adding an x and subtracting 1.
Oh, very good. Adding an x, subtracting a 1. Is that true for the next two? Is that plus x minus 1? Yes. So x minus 1 is our common difference. So the 6 minus 1 here, this turns into a 5 that I want to distribute. So I get 2x plus 5x minus 5. So our sixth term is what? 7x minus 5. So I plug that into my sum formula. Could I divide my 6 and my 2? Yep. That makes that a 3. So I have 3 times 9x minus 5. And then we just got to distribute our 3 and we got our final answer. Get 27x minus 15. So that is your sum in terms of x. That phrase in terms of x just means x is in your answer. Alright, so our fifth example here, we have a large grandfather clock strikes its bell once at 1, twice at 2, 3 times at 3, so on and so forth. What is the total number of times the bell will be struck in a day? And use an arithmetic series to solve the problem and show your work. Have you guys ever been around a grandfather clock?
Yeah.
Especially at night? Oh, it's not that it's scary. It wakes you up every hour as it rings the little bell. It's annoying. I hate it. So for this one, it's easiest if you kind of start writing your series as you go. So at 1 o'clock, the bell will ring once. At 2 o'clock, it'll ring twice. 3 o'clock, it rings 3 times. All the way until we get to 12 o'clock. And then what happens?
Repeat.
It just repeats the cycle. It doesn't do military time, so 1 p.m. isn't 13 rings, thank goodness. 2 p.m., 14 rings, that's just silly. So what we'll want to do is find the sum of this series first, and then do what with it?
Multiply it.
Just double it. And then that's going to give you for the whole day. So let's use our formula. Although I think cuckoo clocks are worse than grandfather clocks.
Is that the one with the squirrel?
No, that's where it has a bird that comes out and goes cuckoo. Cuckoo.
My grandma has one. I don't know what's up with it. Just
So our n is going to be 12 because we're going from 1 o'clock to 12 o'clock, so we're looking at 12 different times here. Our first term would be a 1. Last term would be a 12. So let's figure out what that is going to be. So our sum for the first 12 hours, 78. So again, though, we have to take that and double it. So 78 times 2 would give us 156. 156 times in one day. Which I am willing to bet there are probably people who have sat there and actually counted it for the entire day.
So you can tell now, but you weren't the answers.
Alright. How are we doing? I promise you guys not too bad, right?
Has there actually been people that would go up to 100?
Yeah?
Yeah. Wait,
Yeah.
go back to first. I'm like a region.
So our geometric series, what do you think our geometric series will be? No.
Subtract.
No.
How about that?
I'm not going to answer.
Series is still a sum, but this time instead of it being an arithmetic sequence you're adding up a geometric sequence. That's the only difference. So your geometric series is just a geometric sequence added all together. So there's our formula for it. Again, our S would stand for what? Sum.
I started.
Our A sub 1 is our what? First term. Our R stands for that's our common ratio. Remember, that's what you're multiplying by each time to get you to your next term of your geometric sequence. And N would be number of terms. So the one nice thing is we don't have to know what our last term is like we did for our arithmetic sequence. You just need to know the first term, what's your common ratio, and then we can figure out our sum from there. Let's take a look at our first example. We have find the sum of the first 5 terms of the sequence. So I'm going to write my sum formula down first. So S sub n equals A sub 1 times 1 minus r to the n all over 1 minus r. What would our n be? 5, because we're finding the sum of the first 5 terms. Our first term is a 2. We have to figure out the r value. What are we multiplying by? Negative 3. So our r is a negative 3. So then we want to plug this into our calculator. Now when you're doing this in your calculator, I strongly recommend using your fraction key. So your alpha, y equals, and then your choice 1 to give you that fraction. So again, we had written 2 parentheses 1 minus parentheses negative 3 to the 5th. That's our top. And it was over what? 1 minus negative 3. Oh, my negative didn't hit. Negative 3. There we go. So then enter, what do we get? 122.
Why did you plug that into y instead of just...
The alpha y gives me the calculator, or the fraction. And so I didn't plug it into my y equals. It gave me my, that's how I get my fraction.
If I like type in a decimal, like...
All right, number 2, given the series 3 plus 4.5 plus 6.75, they want us to find the sum of the first 10 to the nearest 10th. So that's kind of your hint. We're going to end up getting a decimal answer here. So again, let's write our sum formula. So S sub n equals A sub 1 times 1 minus r to the n all over 1 minus r. Nope, that one's given to us. The only one you have to memorize is the arithmetic series formula. So we're going with an n of 10. They told us to find the sum of the first 10. What is our first term? 3. What is our r? Well, remember, take a term, put it over the one before it. That gives you your r value. So 4.5 divided by 3. So you should get 1.5. So if you can't see it right away, that's what you got to do. Take a term, put it over the one in front of it. And then just check, is 4.5 times 1.5 6.75? Yeah, and then that times 1.5, 10.1.25? Yeah. So our r value is going to be a 1.5. So you haven't already done so. Let's have you type that into your calculator. And again, we're going to be rounding our decimal to the nearest tenth. All right. Next one. Error. So example 3, we're told to evaluate that series using the sum of a geometric series formula. This is my little hint to you. We have to figure out what the r value is first. So again, how do we figure out the r value? You divide one term by the term before it. So like 1/9 divided by negative 1/3. Look at you. Which does give us a negative 1/3. So our r value is a negative 1/3. So now let's have you go ahead and plug that into your formula. Shayla. So what is our n? How many terms do we have? 4. They only gave us 4 terms. Our first term is a negative 1/3. So we got lots of negative 1/3 to plug into our formula this time. So once you got them all plugged in, go ahead, plug it in your calculator. Let's see what you get. So example number 4. We have in March, the Floyd family starts saving for a vacation at the end of August. They need $1,375. The family starts with $125 each month, and then they add another 20% to their deposit each month. So they want to know, will they save enough? And if not, how much should they start with? So again, this is still going to be a sum, because what they're doing is they are adding the money together that they put into the savings account. So we still got to use our sum formula there. So first thing we have to figure out is, what is our n? If they start depositing in March and they deposit through August, how many times are they making deposits?
Hold on, do we include the March?
Not 5. You do include the March. 6, because they didn't deposit in March, April, May, June, July, and August. So they deposit for 6 months. So S of 6 equals, first month they put how much in? 125. Each month they deposit 20% more. So what would our R be? Got to add something else to your point too. It's 20%.
1.2.
And then we got to make it a gross. So 1.20%. To the 6th power over 1 minus 1.20. So let's have you go ahead, type that in your calculator. Let's see what we get. So will they save enough money? No.
Not their values.
Because remember, that's how much money they wanted up there. So now to answer our second question, if not, how much should they start with? So we're going to plug in for our sum the 1,375. Our n is still going to be 6. What we're looking for this time is your a sub 1. We're looking for that first term, that first month. Still 1 minus 1.20. So there are lots of different ways we could figure out our answer from here. So I'm going to let you guys just kind of go with it and see if you can get it.